All right. That was it for section 2.7, but we're going to do some homework problems together as practice. So for example, let's use the graph of f and the graph of g to draw the graph of f plus g. Okay, so if you remember from part 1, the domain for f plus g is going to be the domain of f intersected with the domain of g. So where the two domains overlap. So from this graph, what is the domain of f? Well, the domain is all the x values for f. F is the red one, so this is -1, -2. So it'll be -2 to 1, 2, 3, 4, 5 to 5. And then what is the domain for g? G is the blue one, is -3 to 1, 2, to 3. So the domain of the function that I'm looking to graph, f plus g, is going to be the intersection. Where do they overlap? So it's going to be from -2 to 3. That's where they overlap. All right, so then I know that the f plus g is going to have the domain -2 to 3. So basically, how am I going to graph f plus g? I am going to add the y values, the corresponding y values. So what is the corresponding y value for g right here, plus the y value for f right here? Well, it looks like this is like -0.8, -0.8, and this one is 1. So the graph of f plus g is going to be at 1 minus 0.8, or added, that will be 0.2. So it's going to start here at 0.2. What about this point? I'm going to add this point and this point. So this point is at -1 and this one is at 2. So -1 plus 2 is going to be at 1. So this, adding this one with this one, is going to take me here. So I can already draw the graph. It's like this for this portion. What about this, for example, this point and this point? I'll add the y value is 0 here, and the y value is 2 here. So 0 plus 2 is going to be here. So it's going to be like this. And then one last value in the domain, this is 1, and this is, I don't know, this is 2, 3, 4, let's say 4.5. So then 1 plus 4.5 is going to be 5.5, so right here. So it's going to be like this. So this, well, I can't tell if you see if it's purple, but the f plus g basically is going to be, it's going to have the domain, the intersection of the two domains, and I just get it by adding the corresponding y value of f plus g, corresponding y value of f plus the corresponding y value for g, and so on, and then I connect the dots, and that's f plus g. All right, let's practice some more with finding domain for composition of function. So what is f composed with g of x? So f composed with g, remember this is f of g of x, and then I'm just going to write down what g of x is. G of x is 8 of x minus 3. So the inner function is g of x. Do I have any restrictions on the domain for this? No, x can be anything, so from -infinity to infinity. Now let's continue. F of 8 of x minus 3, I'm going to look in the function f, and instead of x, I'm going to put 8x minus 3. So it's going to be 8x minus 3 for this x, and then at the bottom is going to be 8x minus 3 for this x, and then add 3. So then if I cancel these 3's, I get this. So what is the domain? The domain for the composition f composed with g. Well, I have no restriction from the inner function, but when I look at this, at the result of the function, I know that the denominator can't be 0, so that means that x cannot be 0. So that gives me that the domain is everything but 0, and this is how we write it in interval notation. Now let's calculate g composed with f of x. So g composed with f of x is g of f of x. So now the inner function is f of x. So this is going to be g of, what is f of x? F of x is x over x plus 3. So now I have to keep in mind that this has to be a valid input for g. So that means that x cannot be negative 3. So I'll have to keep that in mind when I give the domain of the result. Alright, so g of this in g function, anywhere I see x, I'm going to put this whole thing. So it's going to be 8 times, instead of x, I'm going to put x over x plus 3, and then I have the minus 3. Alright, so this is going to give me 8x over x plus 3 minus 3. So then, now the domain of g composed with f, well, I look at this, and looking at this result, I know that x cannot be negative 3. And then I also look at this, and the condition happens to be that it was the same, that x cannot be negative 3. So the domain of g composed with f is x cannot be negative 3. So in interval notation, this is what we get. All right. We can also compose multiple functions, not just two. Just like we can add multiple numbers or multiple quantities, we can compose multiple functions. So f composed with g composed with h of x is just going to be f of, well, look at g composed with h now. So it's going to be f of g of h of x. Sorry. Okay? So I have f of g of h of x. So I'm going to go from the inner function out. So I'm going to substitute what the inner function is. So everything else stays the same. But instead of h of x, I'm going to put what h of x is, square root of x. Now the inner function is this, g of square root of x. So this is going to be f of, let me calculate what g of square root of x. So in the g function, anywhere I see x, I'm going to put square root of x. So g of square root of x is going to be square root of x minus 5. And now all I have to do is evaluate f at square root of x minus 5. So in the f function, anywhere I see x, I'm going to put this whole thing. So instead of x cubed, I'm going to have this whole thing cubed and then the plus 8. So this is the answer for f composed with g composed with h. Let's see what is the domain of this. So the first time I substituted the inner function, I had that the inner function was square root of x. So I have to keep in mind that this has to be a valid input for g. So I have to denote, say that x has to be greater than or equal to 0 because x is underneath the square root. Then this has to be a valid input for f. Well, again, this is the condition that x has to be greater than or equal to 0. And then this is the result, and I don't have to exclude anything else because I already have the fact that x has to be greater than or equal to 0. So the domain is just 0 to infinity, x greater than or equal to 0. All right, what about a practice with decomposing functions? So I need to write g of x as f composed with g. So I need to find what f is and what g is, such that f composed with g gives me 1 over x plus 2. So this is how I like to think about it. So g of x is 1 over something. So that means that my something is going to be my inner function. So that something is g of x, my inner function. So that means that g of x is, well, what is that something? It's x plus 2. And then my f of x is going to be 1 over x. I'll let something be x. So you can check that when you compose these two, f composed with g, you get 1 over x plus 2. One more practice. A spherical balloon is being inflated. The radius of the balloon is increasing at a rate of 3 centimeters per second. Find a function f that models the radius as a function of time t in seconds. So they're asking us to find f of t equals what? where this function f models how the radius changes. So let's think about it a little bit. So I have a spherical balloon, it's deflated, and then after 1 second, its radius is 3 when t equals 1. When t equals 2, the radius is 6, right? So what should be f of t? They should have called this r instead of f, but anyway, f of t. How can I model that it's 3 or 6 or 9? This is just a constant increase of 3, right? So this is going to be just 3t. It increases linearly at a rate 3 centimeters. The average rate of change is constant, right? So this is f of t. Now find a function g that models the volume as a function of the radius. So I need g of r to represent the volume as a function of the radius, r. So for this one, you just got to remember the volume of a sphere formula. So the volume of a sphere is 4 pi r cubed over 3. So this will be your g of r. Okay, so now find and interpret g composed with f. So this is something you should keep in mind from now on. I believe that in your textbook there is a section with all the formulas that you have to be familiar with. Alright, find and interpret g composed with f. So g composed with f is going to be g of f of t. Okay, so it's going to be g of, what is f of t? F of t is just 3 times t. So then this is going to be g of 3t. Well, g is this, where the input is r. So instead of r now, I'm going to put 3t. So it's going to be 4 pi. Instead of r, my input now is 3t, right? So 3t, so this gives me 3 squared is 27, 27 times 4, 28, and keep 2, 88, I think, 88 over 3 pi t cubed. So this is g composed with f of t. So what is this giving you? This is giving you the volume, but the volume as a function of time, not as a function of the radius. So if I want to see what is the volume of this balloon after 10 seconds, I just plug in 10 seconds in here. But if I want to see what is the volume of the balloon when the radius is 5, I just plug in 5 in here. I hope that all makes sense. Alright, so this concludes section 2.7. In the next section, section 2.8, we're going to view inverse functions, and that will be all for chapter 2.